Okay, so let us now discuss question number 21 from the practice sheet. We have discussed up to question number 20. Question number 21 says, a spherical balloon of radius r subtends an angle theta at the eye of an observer. If the angle of elevation of its center is phi, find the height of the center of the balloon. Okay, so this question seems to be a bit confusing. It says a spherical balloon of radius r subtends an angle theta at the eye of the observer. Okay, so what it says is that the balloon subtends an angle theta at the eye of the observer. Now what does this mean? It means that when the observer is looking at the balloon, okay, it says that the angle subtended by the balloon. Now what is angle subtended by the balloon? It means, question number 21, that if this is a balloon, this is a spherical balloon, okay, of radius r with center O, because it says it's a spherical balloon. So the angle subtended by the balloon means the angle, the span of this balloon that I must have to observe this balloon. Okay, to catch this balloon, the span of this balloon will be known as the angle subtended by this balloon at the eye of the observer. Okay, what I mean to say is, for example, if I consider, let us say this is a wall. Now I want to watch this wall. So if I want to watch this, I want to see this wall, the angle subtended by this wall at the eye of the observer will be known as this angle. Okay, angle subtended means the line drawn from the end points of this wall to the eye. Okay, the point at which the person is standing, let us say this is the eye. So the point at which person is standing and looking at the wall, the angle subtended by the ends of the wall in the eye, in the person's eye, will be known as the angle subtended by this wall. Okay, so for this balloon, if I want to look at this balloon, what it says is, if a person, let us say a person is standing somewhere here. Now he wants to observe this balloon. So what does the angle subtended by balloon means? It means if this is the ground level, okay, this is the ground level, the person is observing the balloon, it means the two tangents drawn at the ends of the balloon, like this, the two tangents drawn at the ends of the balloon subtend an angle of this angle theta at the observer. It means my eye is somewhere here and I am observing this balloon. So the complete span of balloon, okay, the complete span of balloon subtends an angle theta at my eye. So I will call this theta as the angle subtended by balloon. Okay, ये वह angle है जिसको इस balloon ने मेरे आँख पे subtend किया. If I move away from this balloon, this angle will converge, this angle will decrease. If I move towards the balloon, this angle will increase. Okay, the span that my eye need to have to observe this balloon will increase. Okay, so let us assume that the eye is at the ground. Okay, let us say eye is at the ground level. So this is the ground level and I am observing this balloon. Okay, this is the angle subtended by balloon. Further it says, if the angle of elevation of its center, what is the center of balloon? This is the center of balloon. Okay, the angle of elevation of this center. Now how to calculate the angle of elevation? It means that to observe this balloon, to observe the center of the balloon, I need to move my head upwards 5 degrees. Okay, I need to move my head upwards 5 degrees to observe the center of this balloon. It means a line drawn from the eye to the center of the balloon, like this. This line, this is the line of sight to observe the center of the balloon. And this line subtends an angle phi. Okay, this line subtends an angle phi with this horizontal. Now I need to calculate the height of the center of the balloon. It means I need to calculate this particular height. My task is to calculate this height. Let us say the point where I am observing is point A. This is, let us say, the point where this vertical line is drawn from the center of the balloon is point B. Okay. Now what I can see is that, let us say, this point is P and this point is Q. Okay. AP and AQ are tangents. Okay. AP and AQ are the two tangents drawn from my eye to the balloon. Okay. AP and AQ. Now this AO line is the line joining the point, that is the point of observation, and the center of the balloon. Okay. AO is what? AO is the line joining center of balloon and point of observation. Okay. And PB, this OB represents the height of the center from the ground level. Okay. I need to calculate this OB. My task is to calculate the value of OB. Now, so this is what we have done. Now try to think in approach how I can get the value of this OB. I am given with only this phi angle, I am given with only this r, radius of the balloon, and this theta angle. Okay, theta, that is the angle subtended by balloon. So it means I need to calculate the value of OB in terms of phi, in terms of theta, and in terms of r. So these are the three values that I need to use to calculate the value of this OB. Okay. So my approach should be such that I need to determine a relation between OB, r, phi and theta. Okay, it's a very important question. So this is what I have written. Now by observing carefully, you have studied the circles chapter. Okay, you have studied about circles. By observing this diagram, I can say that this angle and this angle are equal. Okay, what I can say is these two angles, that is angle PAO and angle QAO, are equal. Why? It's because the line joining center to the external point bisects the angle formed by the tangents drawn to this circle from this external point. Okay, this is a property of circle. The line joining the center of the circle to the external point bisects the angle formed by the tangents drawn from this external point A. Okay, so the two tangents drawn are AP and AQ. So definitely this AO line, which is joining the center and the external point, bisects the angle formed. So it means this angle is theta by 2 and this angle is also theta by 2. Okay. Now observe very carefully. I need to calculate value of OB. Now OB lies in which triangle? What I can see is in triangle AOB. If I observe the triangle AOB, what I can see is with respect to this phi, this OB is the perpendicular and this AB is the base, and this AO is the hypotenuse. Okay, OB is perpendicular, this is perpendicular. Okay, then AB is the base and this AO is hypotenuse. So we have these three quantities with respect to this angle phi. So we have determined this much. Now if somehow I get the value of AB or this AO, I will be able to determine the value of OB. Okay, try to understand the approach. You can solve this yourself, but try to understand the approach, the way of thinking that I am applying on this question. What I am saying is, if somehow I determine the value of AB, or if somehow I determine the value of AO, I can very easily determine the value of OB by using the trigonometric ratios. Okay, so let us think how to determine the value of AB or AO. In this triangle, in this figure, you can see it is very difficult to determine the value of AB, but if I observe carefully and draw a line which joins this O and P, I can see that this angle is a 90-degree angle. It's because the radius is perpendicular to the tangent. Okay, what I am saying is OP is perpendicular to AP. Why? Because radius is perpendicular to tangent. So we have this condition. Now further, if I observe triangle APO, okay, try to observe triangle APO. In triangle APO, this angle is theta by 2. Okay, with respect to this theta by 2 angle, you can see OP is the perpendicular and AO is the hypotenuse. So which trigonometric ratio relates perpendicular and hypotenuse? That is sine theta. So sine theta by 2 is equals to OP perpendicular upon AO radius. Okay, AO hypotenuse. So the value of AO will be equals to OP is R upon sine theta by 2. This is the value of AO. So I have the value of AO. Now since I have the value of AO, I can observe the triangle AOB. In triangle AOB, if I apply this concept, what I can see is, with respect to this phi, this OB is the perpendicular and this AO is the base, hypotenuse. So it means again I need to apply the sine theta, and I can say sine phi will be equals to OB upon AO, which is the hypotenuse. AO is the hypotenuse, OB is the perpendicular. So from here I can write OB is equals to AO sine phi, which implies OB is equals to, now what is AO? R upon sine theta by 2. So in place of AO I can write R upon sine theta by 2 into sine phi. So finally I will get the value of OB as R sine phi upon sine theta by 2. This is the value of OB. Okay, this is the value of OB, that is the height of the center of the balloon from the ground level, that is R sine phi upon sine theta by 2. You can see this question is a bit different compared to the question that we have already solved. Here you need to think a lot. You need to draw this diagram. This diagram is itself is not an easy task to draw. After that you need to approach the question very, very carefully. You need to determine what we should determine, what we need to find, then how to relate this with the given quantities. So in this manner, as I have written, I can see in this triangle, if somehow I get the value of AB or AO, I will get the value of OB. Then I thought to get the value of AB or AO, and I got a clue that to determine the value of AO, it's easy because I know that radius is perpendicular to tangent, so I will get a right triangle here. Okay. After that I have applied this triangle and got the value of AO, then I determined the value of OB. Okay. So this is the solution for 21st question. This is very interesting question and also very, very important question. It do not require lot calculation, but the trick to solve this question is a bit difficult. Okay, so you note this, then we will continue. Okay, now let us solve question number 22. Question number 22 says, from a balloon vertically above a straight road, the angles of depression of two cars at an instant are 45 degree and 60 degree. If the cars are 100 meter apart, find the height of the balloon. Okay. So question says that from a balloon vertically above a straight road. So there is a straight road, and on that road, just vertically above that road, there is a balloon, okay, air balloon, and the angles of depressions of two cars. Now it's very obvious that if I am on the balloon and I try to observe the car, I need to move my head down because the cars are on the road, but I am above the road. So definitely there should be angle of depression. The angles of depression of two cars at an instant are found to be 45 degree and 60 degree. So at some particular instant, the angles of depression of two different cars, it is 45 and 60 degree. If the cars are 100 meter apart, find the height of the balloon. So there are two cars which are 100 meter apart. I need to determine the height of the balloon. So let us draw the diagram. Question number 22. It says that just above there is a, let us say this is a straight road, and just above this straight road there is a balloon. Okay, it's a balloon, let us say like this. This is a balloon, air balloon, okay, and this is, let us say, the height of the balloon. This is point A, let us say this is point B. So I am observing from this balloon and the angles of depression. So it means first let us draw a horizontal line from this balloon. Okay, this is a horizontal line, and the angles of depression, it means there are two cars on the road. First one is like this and second one is like this. Okay, so these are the two cars. This is car C and car D. Now which angle should be 60 and which angle should be 45? It's very obvious. You can see this angle is smaller one, so this angle is definitely 45 degrees, and this angle is a larger one, so definitely this is 60 degrees. Okay, now my task is to determine the value of AB, that is the height of the balloon. It is also given that the cars are 100 meter apart. It means the distance between the two cars, C and D are two cars, and the distance between the two cars is 100 meters. So my task is to determine AB. I am given with this 45 degree, this 60 degree and this 100 meter. So my task is to relate these three values with AB, somehow AB. What I can see is, it's very clear that there are two triangles. Which two triangles? Two right angle triangles. If this angle is 45, then definitely this angle is also 45 because of vertically opposite angles. This angle is 60 like this, so definitely this angle is also 60 degrees because of vertically opposite angles. Okay, now try to observe the two triangles that I am talking about. The two triangles I can observe are triangle ABC and triangle AB and D. Observe the triangle ABC. In triangle ABC, this is AB and this is BC. So I need to relate this AB with this BC. Why I am relating it with BC? Because this CD length is given to me as 100 meter. This hypotenuse of this triangle AC is not at all in the picture. Okay, it is not given. Any clue related to this hypotenuse even is also not given. So I should focus on all those values which are given in the question. Okay, so this is given. That's why I am using the base of this triangle. So this is the height of the triangle and this is the base of the triangle. So I can write tan of angle 60 degree is equals to AB upon BC. What is AB? AB is the height, BC is the base. Tan of 60 degree is root 3. So BC is equals to AB upon root 3. So we have BC is equals to AB upon root 3. Now similarly observe the triangle ABD. In triangle ABD, this is perpendicular, okay, height, and this BD is the base. So I can write tan of angle 45 degree is equals to AB upon, what is BD? BD is equal to BC plus CD. So tan of 45 is 1. I can write BC, in place of BC I can write AB by root 3. So first let us write BC plus CD is 100 is equals to AB. Now BC is AB by root 3. So I will get AB by root 3 plus 100 is equals to AB. Okay. Now using this particular equation, this is an equation in one variable, you can solve this equation and determine the value of AB. Okay. So I am not solving it further, you need to solve it yourself, it is not at all difficult, just the basic calculation is left. Okay. So in this way we need to solve question number 22. Now let us move to question number 23. Question number 23 says the angle of elevation of a cloud from a point h meters above the surface of the lake is theta and the angle of depression of its reflection in the lake is phi. Prove that the height of the cloud is above the lake is h times tan phi plus tan theta upon tan phi minus tan theta. Okay, so this question is very interesting question. Question number 23. Let us solve it step by step. It says that the angle of elevation of a cloud from a point h meters above the surface of the lake. It means the point of observation, the point from where I am observing the cloud is h meters above the lake. So there must be lake. So let us first draw the lake surface. Let us say this is the lake surface, and above this surface, h meters above this surface, let us say this is the h meters above. From this point, let us say this is A and this point is B. So it is h meters above. Now from this point I am observing a cloud, okay, and the angle of elevation of that cloud is theta. Okay, the angle of elevation is theta. So definitely let us say this is the horizontal line. You need to draw the horizontal line, and to observe the cloud in the air, let us say the cloud is somewhere here like this. Okay, to observe this cloud I need to move my head theta degree up. Okay, I need to move my head theta degree upwards. So let us say the cloud is at point C. Okay, this is point C. Now further what it says is, and the angle of depression of its reflection. Now since this is a lake, so if this is a cloud, then definitely this cloud's image will be observed in this lake because of reflection. Okay, the light will strike this cloud, then it will strike this lake, and there is a virtual image will be formed of this cloud. As you have studied in the reflection, okay, in the reflection you have studied about the plane mirror. So this lake will act as a plane mirror. Okay, this lake will act as a plane mirror for this cloud. So definitely the image of this cloud will be formed inside this lake. Okay, and what it says is the angle of depression of its reflection in the lake is phi. So what about reflection? How this cloud will be reflected? This cloud is, let us say this is D point. So this cloud is CD distance above this lake. Okay, since the cloud is CD distance above this lake, or CD length away from this lake, I can say the shadow of this lake, the image of this lake will be formed exactly at this much distance. If this distance is, let us say, x, okay, let us say the cloud is at a distance of x meters above the lake surface, so its shadow, its image will be formed exactly x meters below the surface of the lake. Okay, exactly x meters below the surface of the lake. Now our task is to prove the height of the cloud above the lake is. Now height of the cloud above the lake is x meters. Okay, so it says I need to prove that this height x is equals to h times tan phi plus tan theta divided by tan phi minus tan theta. I need to prove this. Tan phi plus tan theta upon tan phi minus tan theta. This is equal to x. X is the height of the cloud or the distance of the cloud from the surface of the lake. Okay. Now, is anything else given? Yes, it says that the angle of depression. Now, what is the point of observation? My point of observation is A. So, definitely the angle of depression that should be calculated should be from this point A. So, this is the E point, this is the image of the balloon, the shadow of the balloon. So, the line of sight will be drawn like this. This is the line of sight. And what is the angle of depression? This angle with the horizontal, okay? This is the horizontal. Observe, this is the point of observation. The horizontal drawn from the point of observation is this one. So I need to move my head this much degrees or 5 degrees downwards to observe the image of the balloon. So this is phi. So we have this as the phi and we have this as a theta and this height is h. I need to determine the value of x in terms of phi, theta and h. Okay. So let us try to solve this. What we can see is, let us say this is point F, okay, this is the point F. What we can observe is, there are two triangles getting formed in this particular figure, and the most important thing is, this AB is H, this FD is H, then what about this CF? This CD is X. And this FD is H. So definitely this CF is X minus H. Okay. So I can see there is a triangle ACF. Why I have chosen triangle ACF? Because this theta angle is in the triangle ACF. Okay. I need to determine the value of X in terms of theta. That's why I have chosen this triangle. So with respect to this theta, I can see this CF is the perpendicular and this AF is the base. Okay, AF is the base and this CF is the perpendicular. So here I can write tan of angle theta is equals to CF upon AF. Now tan of theta is equals to CF. What is CF? CF is X minus H divided by what is AF? AF is unknown, it is not given, so let us write it as AF. Now, why I haven't chosen sin theta or cos theta? It's because what I can see is the angle theta is in this triangle ACF and the angle phi is in triangle AEF. Okay, try to understand very carefully what I am trying to say is, why I have chosen tan theta, why not sin theta, why not cos theta? It's because this theta angle is in triangle ACF and this phi angle is in triangle AEF, and I can see this AF is common for both the triangles. Okay, what I can see is this AF is common for both the triangles. So AF is common in triangle ACF and triangle AEF in both the triangles. That's why I have chosen this perpendicular in terms of X and H and this AF. Okay. So from here I can see the value of AF will be equals to X minus H upon tan theta. This is the value of AF. Now the phi angle lies in triangle AEF. So in triangle AEF, what I can see is this is angle phi. So this line, this FD is perpendicular and this AF is base. Now what is the length of FD? The length of FD can be seen that this is H and this is X. So the length of FD will be equals to X plus H. Okay, this is ED plus FD. X plus H is X plus H, which is equal to FE. Okay, so FE is the perpendicular and this AF is the base. So in this triangle I can write tan of angle phi is FE upon AF. Okay, in place of FE I can write X plus H, and in place of AF it will be AF only. Okay, so I will get AF is equals to X plus H upon tan of phi. This is the value of AF. This is the first equation, this is the second equation. What I can see is AF is equals to X minus H upon tan theta. AF is also equals to X plus H upon tan phi. So I can equate these two equations. Okay, so by equating or by comparing 1 and 2, what I can see is X minus H upon tan theta is equals to X plus H upon tan phi. So from this cross multiply tan phi and tan theta, you will get X tan phi minus H tan phi is equals to X tan theta plus H tan theta. Okay, now from this let us shift this X tan theta to LHS and this H tan phi to RHS. Okay, so X times tan phi minus tan theta is equals to H times tan phi plus tan theta. So from this I will get X is equals to H times tan phi plus tan theta divided by tan phi minus tan theta. This is the value of X. X is the height of this cloud from the lake. Okay, which is X. So this is what we need to prove. So hence proved. So this is how you need to prove. Try to understand the approach that I am applying on the question. What I have thought is, I thought that we have theta, we have phi and we have H. So I need to determine the height of the cloud in terms of these three values. So definitely I need to determine a relation between these three values. So what I saw is theta lies in triangle ACF, phi lies in triangle AEF. So I need to relate these two triangles and the common between the two triangles is this AF. So I relate these two triangles, I found a relation between the two triangles using this AF. You can see this is AF and just comparing the two and we got the answer. Okay. So these are the clues that we need to use for such kind of questions in which there is something to prove. Okay. So this is the solution for question number 23. Very interesting question. Okay, so we have solved 22 and 23. Okay, so you note this, then we will continue.